am Lindee Wilsoin, a student at Mississippi Gulf Coast Community College. For my MGCCC Honors College membership, I am required to research how calculus will help me in my future major in college.
The rise of calculus began with the Greeks. The Greeks are known for their elaborate architecture. Thus, they had to use integration to calculate lengths of arcs, volumes, and areas. Through time, infamous Greek mathematicians developed theories on conics and proofs. After some time, barbaric tribes invaded the Roman Empire. This followed the complete disinterest in math. However, around 800 to 1200 AD, math flourished under the influence of the Orient. The Orient brought interest in math to the Europeans in the 12th and 13th centuries. Great European mathematicians went back to the original findings of the infamous Greek professors. Fast forward to two important men, Sir Isaac Newton and Gottfried Leibniz. Starting with Newton, he considered how variables changed with time. Newton used quantities x and y, which were finite velocities, to compute the tangent. Leibniz thought of variables x and y as ranging over sequences of infinitely close values. He introduced dx and dy as differences between successive values of these sequences. Leibniz thought that dy over dx gives the tangent, but he did not use it as a defining property. Newton was a pioneer in what we call the limits of functions and evaluating the integrals of functions. Leibniz founded the classical notation for calculus and differentiation. These men laid the fundamental properties, however, European mathematicians picked up where they left off. Mathematician Cauchy developed calculus systematically and consistently. At last, the true concept of calculus was born. Before I explain how math will help me in my career, you might be asking, what even is biomedical engineering? It is a growing career field that stems from mechanical engineering. As stated by Michigan Tech, biomedical engineers differ from other engineering disciplines that have an influence on human health in that biomedical engineers use and apply an intimate knowledge of modern biological principles in their engineering design process. Aspects of mechanical engineering, electrical engineering, chemical engineering, material science, chemistry, math, and computer science and engineering are all integrated with human biology and biomedical engineering to improve human health, whether it be an advanced prosthetic limb or a breakthrough in identifying proteins within the cell. How do engineers use calculus and math in general? First, let's define what calculus includes. Calculus is a specialized math that allows one to calculate the behavior of functions as they near points close to infinity. It is the study of relationships of limits, integrals, and derivatives. Calculus is a solid foundation for all engineering maths, especially physics. As engineering majors move through their curriculum, calculus is a clutch that they hold on to. Here are some specific examples of what type of skills biomedical engineers need to have. They will have to solve problems that involve mathematical modeling and mathematical analysis of biomedical problems, numeric analysis for biomedical sciences and biomedical engineering, optimization techniques and computational methods for medical applications, mathematical models for bioelectromagnetics, biooptics, and neural engineering, inverse problems in biomedical imaging, including image reconstruction algorithms, methods for biomedical image processing and visualization, computational methods for psychological signal processing, multidisciplinary combining algorithms, modeling and optimization, application of mathematical theories to biomedical sciences / the engineering field, and applied statistics in medical and biological sciences. I found a great interview with Kate Hilpish. She has been working at the Senior Biomedical Engineering Company for 12 years. She detailed how day-to-day life was for biomedical engineers. The question was, how would you describe your particular area of science and/or engineering and what you do? She replied with, biomedical engineering involves engineering with medicine and biology. Simple, right? But biomedical engineers do all sorts of different things. My job is specific to helping find medical therapies for patients with heart problems. Other biomedical engineers look at how different substances interact in the human body and how to get images of our bodies. My job is all about math and medicine. I found this so interesting. The main concern I have had over picking a career is the thought of boredom. Through my research, I have found that biomedical engineering is so broad and there are so many things for me to do.
I have found a great video that wraps up what exactly biomedical engineers do. It gives great insight of the real biomedical engineers' lives. Let's watch this short video.
So I thought I wanted to be a doctor. And then I discovered biomedical engineering, and I realized that instead of saving one patient at a time, if I could create something, I could save thousands of lives.
I think I've always been fascinated with the brain and how it works.
I was interested in medicine and I was interested in engineering. So biomedical engineering brings these two big fields of medicine and engineering together.
So you want to be a biomedical engineer? Well, you've come to the right place. I'm Bruce Wheeler, adjunct professor in the Department of Bioengineering at UC San Diego and past president of the IEEE Engineering in Medicine and Biology Society. Join me on a journey through one of the most exciting yet challenging and competitive fields.
The body actually has engineering principles built into it already, and it's just a question of uncovering them.
I've always been interested in how complex the heart is and everything that goes into making the heart function.
I basically want to help people walk again.
Biomedical engineers are dreamers, but we dream things that can become a reality.
In this overview of biomedical engineering, we'll give you the opportunity to sample and explore the many areas of focus within this vast field. Along the way, you'll meet world-renowned leaders in biorobotics, neural engineering, nanotechnology, tissue engineering, wearable sensors, and much more.
You have to love how the body is put together, how beautifully complicated it is.
You can challenge yourself constantly.
They'll expose you to their work, offer advice, and tell you about their own backgrounds.
A biomedical engineer is a person who is passionate about working at the interface of technology and medicine.
And I'll put you to work, giving you exercises that challenge you to try on the various areas to see where you might fit. Once you decide what areas pique your interest, we'll get you thinking about how to craft your own career, if you have what it takes and what it's going to take to get you there.
That was so fun. Learning about new career fields are so entertaining. To sum it all up, biomedical engineers use calculus as a foundation. It gives them the groundwork they need to understand more complex math problems. Thus, it's very important for every engineer to fully grasp every concept that calculus is trying to teach them. I also learned that biomedical engineering is such a vast field. It's so cool that I will get to work on something vastly different each day. With that, I am very honored that you watched my presentation. Thank you so much.